Hello students, welcome to the session on data structures. In our today's session, we are going to begin with the fourth unit. See, we are having AVL trees in third unit, but it is not that much important. If we are having time, we will revise that also. Okay, but right now we will begin with what? Unit 4. That is your graph definitions. Okay, and see, graph is also a data structure which will fall under non-uniform or else non-linear data structure. Okay, graph is the non-linear data structure where it will be storing the data as per our requirement. Okay, and the graph can be defined, graph can be having a definition like what? A graph G is denoted as G. Okay, and it is a combination of vertices and edges where V stands for vertices and E stands for edges. It may be pronounced like this, ma. A graph is a set of vertices and edges. Okay, it may be pronounced in any manner. And now we will go with what is vertex and what is edge. We'll be having different kind of terminologies that we are going to use in our graph. Okay, that we are going to see in our today's session. Just listen it carefully so that you people can understand the few more things which are related to your graphs. Okay, right now I'll go with the picture over here. See here, we will be storing the data as we have done in the tree structure, but in our tree we will be not having any closed loop. You people are already familiar with the tree structure, that we will be having a root node and we will be having a child over here, and for the child we will be having again a child. Okay, we'll be having like this. The structure of tree will be like this, but in our graph structure we will be having the similar structure for your similar structure to your tree, but it can have a closed loop. See here, in this example we are having a closed loop for 6 5 2, and you can take like this 1 2 3, and 3 vertices are connected like this. Okay, when it is having the third session, when it is having like this 1 2 3 connected with the 2 edges, it may fall under graph as well as it may fall under tree. But if you are having the third edge like this, then it will fall under graph, it won't fall under the tree. That is what the major difference that you could find in your trees and graphs. For example, graph below, you consider whatever the numbers that we have placed over here, they will be called as what? Vertices. 1 2 3 4 5 6, whatever the numbers, right? And these are the vertices that we are calling it as. And edges, what do you mean by edge? Edge is nothing but a line which will be combining the pair of vertices. See here, we are having 1 and 2 noma, then in order to combine these two lines we are using this line. This line is an edge. We are having 2 5 as an vertices, and in order to combine them we are using this line, that will become edge. We are having 6 and 3 as our vertices, and in order to combine them we are using an edge, like this. Every path are the line which will connect two vertices are called as what? Edges. Okay, these are the few descriptions that will analyze you people what is the graph actually is. And we will go with one more slide where you people will be having one more definition over here. A graph consists of vertices and set of edges. Graph can consist what? Set of vertices and set of edges. Here you see what is vertex. Vertex is a single piece of information. Vertex is a single piece of information held in the graph, like as I already told you people, 1 2 3 4, whatever the thing that you are going to place in your notes, and if not A B C D, whatever the things that you are placing over here. Okay, and edge connects two vertices. When it is connecting two vertices, then it is called as what? Edge. That is what we have discussed earlier. Okay, now we'll go with the next slide where you people will be coming to know what are the terminology that we are going to use in our graphs topic. Okay, try to understand this, ma, as you have come across with the term called graph. These graphs are categorized into two types, like directed graph and undirected graph. Okay, what do you mean by directed graph? While you are showing the path, while you are showing the edge from one vertex to other vertex, if you are showing the path from which vertex to which vertex we should go, then it is nothing but a directed graph. See here, in this first case, A is going from A to B and B is coming from B to C. Like that, in the next case, A is going from B, B is going from C, going to C, and C is going to A in this case. And in the same way, A can go to B, A can go to C, and B can come to C. It cannot be reversed. In this second case, if you are observing, we can go from C to A, but you should not come from A to C, because it is a directed graph. You should go in that particular direction in which they have given. Okay, this is what the directed graph is. In the next one, undirected graph. If you are just specifying the edge, but if you are not specifying the route to go, then it is called as what? Undirected graph. Like see, A, B, C are the vertices, then AB is an edge which is not having any direction, so it can go in this direction, A to B and B to A. But in the first case, we can go from A to B only, we should not come from B to A. In the second case, you see, A, B, C are the vertices. C can move from, in the first case, you can move from C to A, but you can't move from A to C. But in this case, you can move from A to C and C to A. In the both direction, you people can move. Like that, if you are specifying a particular direction in which you have to move from vertices to vertices, then it is a directed graph. If you are not specifying that, then it is a undirected graph. That's it. It is very simple topic, but try to understand what we are going to discuss. That's it. Okay, and this is the first terminology that you have discussed, that we have discussed. And next thing that we need to discuss is here adjacent vertices. What it is? Adjacent vertices. Vertices having a common edge is called as what? Vertices. Adjacent vertices means to say that in this example, if say suppose if I am taking the example of A can have a common edge to B, A can have a common edge to C, A can have a common edge to E. So this B, C, E will become the adjacent vertices. If say suppose if I am taking one more example over here, if consider that if we are observing this D can have a common edge for C, D can have a common edge for E, but we can't have more than that. So E and C will become what? Adjacent vertices for your D. In this way, like that, we will be using what? Adjacent vertices. And adjacent edges, you see, adjacent vertices of adjacent edges are AB and AC and AE. Okay, means to say that from a single vertex, whatever the paths that you are having, whatever the edges that you are taking in order to draw the graph is nothing but what? Adjacent edges, like AB, AC, AE. In the same way, if you are considering EC, ED and this one, okay, BA and CA and CD, see here, CA and CE and CD, which is coming from C. Okay, if you are going for BA, it is having only one thing, that is the reason we are not taking it if you are considering it from B. Okay, that is what the adjacent edges are. Okay, and next that you can observe is parallel edges. See while you are having a parallel edges, you should understand this, that if a pair of vertices contain more than one edge, if a pair of vertices contain more than one edge, means to say that here in this example, A is a node and C is a node. These are the two pair of vertices and they are having more than one edge. See here, this 10 is one edge and this 12 is one more edge. So these two will become what? Parallel edges. For example, you can draw your own example also. Say suppose A, B and C. So consider if I am having A to C and C to B and B to A. But if you are having one more path from A to C and C to A, both will become what? Parallel edges. These two will become what? Parallel edges. Like that, the parallel edges will be there in this. Okay, and see here, the next one is complete graph. Okay, what it is? Complete graph. Complete Complete graph is a graph which will be having edges to all of the vertices from it. Okay, if a vertex is present in the graph, if it is having edges to all of the other vertices, then it is called as what? Complete graph. Like see, in the first example, if you are having two vertices, then it is having a connection in between them. So it is nothing but what? It is a complete graph. See, in this case, if you are having this vertex, it is directly having the connection between them. If you are considering this, it is having directly connection between all the vertices. In the same way, in the remaining two also. Okay, if you are having directly connection between the vertices, then it is called as what? Complete graph. Okay, now we'll go for the next one. The next one is cyclic graph and acyclic graph. See here, ma. See, observe the examples. See, in the first one, you can find this. Okay, a graph with at least one cycle is known as cyclic graph, as we are having only one cycle over here. A, B, C, D is forming a cycle. If it is not forming any cycle, then it is nothing but what? A cyclic graph. Okay, at least you should have one cycle, then it is called as cyclic graph. If you are not having any cycles in the graph, then it is called as a cyclic graph. From these examples, you people can easily understand this. Okay, I hope it is clear to you people. See, ma, one more example that I could go for is connected graph and disconnected graph. Okay, say suppose if you are mentioning the path like this, A, so example, I will take example here itself. Okay, consider that we are having A, B, C. Three vertices are there, and B is going from B to A, and C is also going from B to A, and C is also going from B is also going to C. See here, we are not having any path to reach what? B. B can go from B to A, B can go from B to C, but we can't reach from C to A, C to A to B also. Why? Because it is not having any direction over here. Why? Because we are drawing a directed graph over here. We are not having any path to go from C to B. We are having path from what? B to C only. Okay, that is the major problem that you people can see. Okay, and when I'm talking about the path, I can say that if you are going from B to A you can go, and B to C you can go, and C from B you can go to C, and from C you can go to A. This is a path. Okay, like this we will be having what? Connected graph and disconnected graph. It is a disconnected graph. Why? Because we can't reach B in this particular graph. But if you are having undirected graph like this, okay, we can go from any edge to any edge, A to B, B to D, D to C, and then C to A. Okay, like that if you are having, then it is nothing but what? Connected graph. These are the few terminologies which are related to your graphs. I hope you people might have got the basic idea of your graph and see the basic definitions and basic terminology that you need to have in your mind, so that you people can understand the remaining part of your graph. Okay, and remaining things I will discuss in the next lecture. That's it for now. If you are having any doubts, just let me know by your messages. Go through your material so that you people can understand the graphs in more easiest manner. Okay, that's it for now. See you in the next one. Thank you.